which I think is now on. Thank you. Now maybe we'll get some more citations on that paper, Eric. The third author is Bridget Terry Long, my dean, which is we're recording this, so I need to make sure that's on the record. So thanks for having me. It's really quite nice to be back here today, and I've had some great conversations already. I'm going to be talking about this paper today, which is joint work with my co-authors Esteban Acejo and Teresa Romano at ASU and Emory, respectively. We're still relatively early in the process of this paper. I think this is the third seminar that I've given. So we definitely want your feedback. And as we would say at Harvard, econ rules apply. So you should interrupt me. Frankly, if you don't interrupt me and ask questions, I will think something's going wrong and that you hate the paper. So even if you don't have questions, make something up so that I feel more comfortable standing in front of you and talking. So what are we going to talk about today? We're going to talk about teacher evaluation and how it does or does not change the behavior of the teachers being evaluated. And the motivation for this sort of goes back a long way in economics to sort of the principal-agent problem and the idea that evaluation, which is a sort of combination of some performance measure and some incentives, can shift the behavior of employees closer to what their employer would prefer. One particular concern that arises in this discussion of employee evaluation is the idea that evaluation can, worker effort and decisions might be distorted, and we're particularly concerned about that when the job is what we would call a multitask job, where there are lots of different things we're asking someone to do, and the evaluation measure might only measure some of those. Well, that's not good. It's just going to do that periodically? All right. My computer to power? Anyway, so if somebody has multiple tasks and the evaluation measure is only capturing part of those tasks, then someone might respond by focusing their time and attention on that subset of tasks that's measured by the performance measure. That's the basic story in the Holmstrom and Milgram paper, which is sort of the seminal theoretical paper on this topic. In fact, even in the Holmstrom and Milgram paper, the concrete examples that they talk about are teaching. So we're sort of following this tradition. We're also motivated here by something that will be no surprise to people in this room, which is the resurgence of performance evaluation in public school management and policy. And that's both, starting in the 90s and in the 2000s with No Child Left Behind, and also the sort of more recent resurgence of teacher evaluation. So we've put a lot of our eggs as policymakers and school managers in this evaluation basket, and there's still a lot we have left to learn, including, I think, some of the things we're going to talk about today. All right, so let's talk a little bit about existing evidence on this topic and where we think our contribution fits. So I'm listing here topics on which we think there are unintended responses to evaluation by teachers. And we could group them. Personnel economists might group them into these two big groups. One is manipulation, which generally speaking is things that like cheating, where someone is manipulating the performance measure itself. So all of these things sort of feel like cheating, but there's of course outright cheating on student standardized tests. There's cheating that's been documented by prior papers in the form of schools deciding who should be tested. So you might not test some students if you think that they are going to reduce your school's average test score. And there's definitely empirical evidence of that. No Child Left Behind tried to solve that by setting these sort of standards for how many students needed to be tested. There's also sort of manipulation in the form of teaching students test-taking tricks which are orthogonal to what we're trying to measure. So teaching them how to answer multiple choice questions in a way that makes their test scores go higher, but doesn't actually demonstrate any knowledge that's useful outside of that context. The other category, and the category in which we're going to be working, we sort of broadly labeled distortion, especially shifting of effort, teacher and school effort, across different tasks. So, so it's important to pause and think, what are the tasks that teachers are assigned in their jobs? And there are different ways to think about that. One way is that they have that they're asked to teach different subjects. An elementary school teacher is supposed to teach English and math, and there's and other subjects. And there's some evidence from Tom and Brian Jacob and others that that teachers do respond if their students are tested in math and reading, they spend more time on math and reading than other subjects that are not tested. Another way to think about a teacher's tasks, which is different from different subjects, is actually, and the one we're going to focus on today, is to think about different students assigned to a teacher as different tasks. So like there are 25 kids in the class, those are 25 different tasks that I've been assigned as a teacher. And there's a nice paper by Derek Neal and Diane Sanchenbach that shows empirical evidence of a pattern of behavior by teachers that you have all heard of before, whether or not you've heard of this particular paper. And that pattern of results is this. No Child Left Behind and policies like it incentivized a very particular kind of performance measure. That is, the proportion of kids who pass the test. So what that incentivizes me to do is to focus on kids who are at the margin of passing. So I should spend most time with kids who might or might not pass. I should spend less time with kids who definitely will not pass, and less time with kids who definitely will pass. And they show some evidence of that. There are others. I'm spending too much time on this, so I'll just skip to the end and say, so this idea of students as tasks is where we're going to focus today. And let me tell you what we do. So we study a short-lived change in North Carolina's evaluation rules. So during the entire period that we study, it was the case that teachers in schools are evaluated based on their students' end-of-grade tests in grades 3 through 8. This includes both No Child Left Behind, with which everyone is familiar, and North Carolina's own state policy, which is called the ABCs of Public Education, and I'll say a little bit more about that, but basically the same thing, evaluated based on test scores. So that's true of all of the data that I'm going to show you. Then for 4 years, from 2009 to 2012, students who failed that initial test at the end of the year were retested 2 to 3 weeks later, and then this is the key point, only the higher of the initial test and the retest counted for the school and teacher evaluation measures. So the students who were retested could only make the evaluation measure go up, but students who weren't retested weren't useful. Okay, but this is not a paper about retesting. I'm not going to, at the end of today, I'm not going to tell you that retesting is good or bad. We're going to use this policy because it generated differences in incentives for teachers. So this retest policy led to new incentives for teachers, which differed sharply across students. So I sort of already started to say this, but here's the sort of unusual incentives. Here's the unusual incentives. So effort on the part of the teacher given to retested students can only improve the teacher's evaluation score because they use the maximum of the two scores. But effort given to non-retested students will have no effect on the current year evaluation score. So all of the incentive, there's a whole bunch of incentive for a period of 2 to 3 weeks, there's a whole bunch of incentive to spend time with the retested students and not the other students. However, even though the incentives of the evaluation policy are starkly different across these two groups of students, it's still the case that the retested and non-retested students who were near the cutoff, there's going to be an RD involved in this, but students who were near the cutoff are arguably identical. That is, there are students who are equal in their educational sort of desert of teacher effort. They have equal claim on that effort. They have equal returns to that teacher effort. And yet some of them are going to be retested and some of them aren't because of this arbitrary rule. And the incentives will be for the teachers to give more effort to the students who are retested.
Now, I'm wondering, though, what about the incentives for the students? Was this something they had to pass this test to graduate or to move on or something like that?
An excellent question. There weren't many incentives for students. The passing this test was one factor in the decision about whether or not to retain students in grade. In practice, very few students are retained in grade, but I'll have more to say about that later on. But that doesn't explain the results that I'm going to show you in the end. There are other considerations in this family of maybe the students responded to this label of needing to be retested, and I'll say more about that a little bit later on. We don't think that that's the case. Okay, so our identification strategy you can think of as a difference in RD or an event study of RD estimates, and it's built up with these inputs. So first of all, at the core, we're going to have an RD estimate, where we use students at the pass-fail cutoff of their math score, their initial math score in year T. And the outcome in this basic RD is going to be their math scores 1 year later at time T plus 1. So we can do that little RD in any given year, and we're going to do that, and compare those RD estimates over time, before the policy, during the policy, and after the policy ends. That's the sort of difference in RD or event study of RD's design. The main result of the paper is that being retested with any accompanying treatments improves math achievement by about 3/100ths of a standard deviation 1 year later. And we're going to argue that the likely mechanism is that teachers gave more effort and students learned more between the initial test and the retest. That is, the students who were retested learned more between the initial test and the retest. They got more instruction, more effort from their teachers. Okay, so I'm going to give some additional details about the setting and treatment and then move on from there, but I'll pause and see if people have questions at this point. Okay, so, Eric, did you raise your hand? Oh, no, all right. That's right, to make me feel comfortable.
I guess I was just trying to think about whether they use the initial passing for other things as well.
Yeah. I'm going to show you some evidence that in fact they did, but that was constant across this time period that we have before, during, and after. And we'll be a little bit more specific about the identifying assumption, but one of the identifying assumptions is that there can be other things that differ at the cutoff as long as those things would have been constant in the absence of the retest policy. Yeah.
So 300ths of a standard deviation doesn't feel like very much. Do you have a super huge sample?
We do have a super huge sample. We have the entire state of North Carolina over like more than a decade. So we have lots of statistical power. I'm going to argue that it is reasonably big, and I'll say more about that later. One way to think about it is to think about the total teacher contribution to student test scores. This is a large proportion of that. Or you can think about, there are some other estimates of adding additional instructional time, and it compares favorably to those things as well. But the amount of added instructional time is not enormous. It's not trivial, but it's not enormous, 2 to 3 weeks. So, all right. Yeah, Josh?
That's kind of thinking the opposite, right? It's like there's 30 weeks in a school year or something like that. Like, so how many standard deviations are students growing in a given year?
Well, so that's an estimate people have tried to sort of pin down, and I'm not sure what we should think about all of those estimates. I'm going to show you some estimates that I think are better identified. But this is, 10 or 15% of the total school days in the year is 2 to 3 weeks. So it's not small. It's not huge, but it's not small. Okay, great. So a little bit more about the setting. I mentioned already we're doing this work in North Carolina. We're going to use data on all grade 3 through 7 students from 2003 through 2016. That's about 2,000 schools and 200,000 kids per grade per year. North Carolina is about half minority, half free lunch eligible, and 10% English language learners. All the data come from the North Carolina Educational Research Data Center at Duke, which you all can access as well. They're pretty great about making the data available. Yeah. Oh, sorry. Yeah. This is all public school students. Okay. So I said we're going to use data from 2003 to 2016. The following things are true about all of those years in the data. First, students were tested annually in grades 3 through 8. Second, No Child Left Behind was operative and its successor. And the key performance measure for No Child Left Behind, which everybody in this room probably knows, is the percent of students who pass the test. That is, the passing is scoring at level 3 on the test, or proficient. There's a state level performance measure called the ABCs of Public Instruction, and its performance measure was actually a combination of something that looked a lot like the NCLB measure, but also mean student test score growth in the school. So we have both levels and growth, but at the end of the day, student test scores mattered for the evaluation of schools and teachers in North Carolina for this entire period that I'm showing you data for. Then, in what I'm going to call the retest years from 2009 to 2012, these rules applied. Students who failed the initial test were retested 2 to 3 weeks later, and only the max of the initial and the retest score counted for No Child Left Behind and ABCs. And just to sort of emphasize the key events here, the initial test happens roughly sometime in May. The retest happens sometime in June. The May test score, that initial test score, is our running variable in the regression discontinuity. And our outcome is students' math test score 1 year later. That's the first time that we observed math test scores for all the kids in the study. Only the retest kids are scored here. So in fact, for most of the talk, I'm not going to use the retest scores. I will briefly in the end. All right, just to pick off a few other questions that are usually asked. The state required retesting for all students who scored at level 2. The state divides its test up into 5 levels, 1, 2, 3, 4, 5. Retesting was required for level 2 only, and about 98% of kids were actually retested. Our RD uses the cutoff between 2 and 3. So you should be thinking, if you're thinking about RD, about what treatments were assigned at the cutoff. Well, there's, of course, the one we're focused on, being retested and any interventions that were linked to retesting. But as Eric was mentioning, there are also potentially other interventions which would have existed absent the retesting that are assigned discontinuously at the cutoff score. And we'll come back to that. There were some, but they seem to be constant across this period.
So I'm trying to understand the timeline. So you
Yeah.
have these spring tests, and then you're looking at the next year. So they've had another teacher in between this time. And so does that
Correct.
have any indication of whether or not a student is a pass the retester?
Say that again?
So if I'm getting a new crop of students, do
Yep.
I know that you were a retester, and so I might,
Yeah.
okay.
So that's a possibility. The fact that you were retested should be readily knowable. And it's a possibility that they were treated differently by their teacher. We're going to show you that the kind of teacher they got was not changed. The kind of peers they got were not changed. But that is one possible explanation for our results, is that the teacher the next year gave them extra effort. That would still be, I think that would still be distortion in the way we're thinking about it, but it would be different from what we think is the likely mechanism.
And also interested in the fact that you're saying only level 2
Yeah.
And they weren't even retested. Was there some like?
They could choose to be retested.
Okay. So I guess what I think is interesting about that is so there's kind of a like if they were really bad, we're not even going to try and get them to pass, and
Yeah.
we just think they can't pass.
Yes. Well, we're being recorded, so I will not say anything more about that, but you can infer from that what you will. Oh, Michelle, did you have your hand up? Sorry. Okay. Okay. So let's move on then and talk about the main estimate. And the easiest place to start, one nice thing about regression discontinuity is, one nice thing about both regression discontinuity and event studies is that they are highly visual. So I'm going to start with just two pictures. So the first picture is the sort of standard regression discontinuity picture, where on the x-axis we have the running variable, that is your initial test score at time t, and on the y-axis we have the outcome, your test score at time t plus 1. And we've centered here around 0, which is the pass-fail cutoff. Here on your left is the retest years, 2009 through 2012. And the only difference between these two figures is that I've zoomed in on a tighter bandwidth here, but they are identical estimates. And you can see that 0.03 difference in test scores at the cutoff in the retest years, but in the non-retest years, before and after, we don't see visually. Like, there's no identification coming from the pictures, of course, remember, but they are helpful in RD for sort of establishing what it is we are estimating. And what we're estimating is the size of this jump between the lines at 0. Okay? So we do this regression discontinuity estimate in every single year of the data we have. And then in this picture, I'm just plotting each of those estimates and their confidence intervals. And I've just normalized everything here to the 2008 year. It turns out that actually the estimate in 2008 is pretty close to 0 anyway, but everything is normalized relative to 2008. So before the retest policy happened, we basically had very little discontinuity, if any, in student test scores at this pass-fail cutoff. Then during the retest years, 2009 through 2012, we see this bump, see this improvement. And then after the retest policy ends, we definitely don't see that improvement anymore. If anything, we might see some negative effects on the kids who failed. Okay? That's, by the way, this is sort of the whole paper, this picture. So if there's some reason why you think we might be misleading you in this picture, you should ask about it now, but this is sort of the idea. Individual year-by-year RD estimates, and we look at an event study of those estimates and show that it improved during the retest policy. Yeah?
Did you look at all as to why it seems like the years are lower than the years
Yep.
before?
So there are a couple of other things that change before 2014. And we could spend a whole 30 minutes talking about all of those changes. This is when we start to have sort of changes in No Child Left Behind and the waivers. There's also a change in the test itself in North Carolina at this period where they divide the, actually there were, I misspoke earlier. I said there were 5 categories. There were 4 categories for the test. Actually in this, starting in 2015, there were 5 categories. It's not entirely clear where the pass, fail, retest, not retest cutoff would have been in this period. I'm showing you the one that shows the largest negative effect here. If I do it the other way, it moves these things up, and the confidence intervals include 0. I'm going to also show you that our estimates don't depend on just, you could just ignore, in fact, all of this post period, and you would still get the same point estimate. But other things start to change, in short, after 2013, but it doesn't seem to affect our basic takeaway. It's just fun to have like both pre and post policy data, so I can't resist showing you the post policy results as well, even though they're a little bit more complicated in what was going on. Great question. Sean.
The RD at the category 1 threshold.
We can't, I mean, there's no reason mechanically why we couldn't. And we should. I'm trying to think. I think I know the first stage. It's not 98%, but I don't know anything more than that.
Why do you care about the first?
I don't know that I do. I'm just trying to think of what I actually know about that threshold. I don't know the outcome, which is what you were asking about. Okay. But it's hard to carry around all of these estimates for the rest of the talk. So we're going to take this event study of RD figures and collapse it into something more manageable, which is a difference in RD. Intuitively, what we're going to do is compare the mean of these 4 policy years to the mean of the non-policy years. And we can estimate that in a specification that combines the basic features of an RD specification and the basic features of a difference in differences specification using local linear regression to estimate it. So the outcome is students' test scores at the end of year t plus 1. We're going to have a flexible or a linear function of the running variable, which is your year t test score. And in fact, we're going to allow that function f to have different slopes above and below the cutoff. And we're going to allow the slopes to differ year by year. Then the indicator b is equal to 1 if the student fails the initial test. That's the RD sort of treatment variable. And the indicator r is equal to 1 during the retest years. That's the, during the policy indicator. So we have main effects for being below the threshold and main effects for the policy, and then the interaction of those, and delta is what we're interested in. It's that difference in RD estimates. In all the estimates, we for a bandwidth, in this case, we're going to use all of the data at level 2 and level 3. But I'll show you that our estimates aren't sensitive to alternative bandwidths. In fact, they're quite stable. But that gives us the sort of most precision. In fact, the reason they're quite stable is that, test scores on test scores is highly linear, right? So we're not like moving away from the cut score doesn't lead to much bias in a local linear regression. Okay, so here is a table showing the key estimates from that specification. And most of the estimates I'm going to show you look like this, so let me just explain the structure of this table. Each row is a different regression. And in the column 1, what we have is the RD estimate of the difference at the pass-fail cutoff in the non-retest years. So this is the RD estimate pooling all of the non-retest years. In column 2, what we have is the RD estimate is the difference between the RD estimate in the retest years and the RD estimate in the non-retest years, the difference in RD estimate. So there's that 0.03 that I've said a few times now, which is 0.03 is sort of the difference between the mean of those 4 points and the mean of the rest of the points. Yeah? Okay. So with that basic setup, let's talk a little bit about identifying assumptions and about magnitude before we move on to talking about mechanisms. So what identifying assumptions do we need here? The first thing we need is the sort of standard conventional RD assumption. That is, we need continuity of potential outcomes at the pass-fail cutoff. We do the sort of conventional tests. First, we will remind you it's not a test, but it's an empirical detail, or a detail of the empirical setting, that the pass-fail cutoff is determined by an item response theory scaled score, not by the number correct. So even if you had in mind that like kids were trying to get one more question correct so that they wouldn't fail, like that wouldn't necessarily mean that they would pass, it would be very hard for them to manipulate the cut score. And as a result, the density of our running variable is smooth in the way you would expect at the cutoff. And we test a whole bunch of pretreatment covariates and show that they're also continuous at the cutoff, at the pass-fail cutoff. All things which you would expect under this assumption of the continuity of potential outcomes. So that's sort of identifying assumption one, which should be familiar from other RD studies. Second identifying assumption is sort of akin to, it takes the place of the parallel trends assumption in the standard difference in differences paper, but we're going to try to state it as sharply as possible here, and that is that the RD estimate, this is an assumption, that the RD estimate from the non-retest years, 2008 and before, 2013 and after, would have been true in the retest years absent the policy. So the assumption there is if this retest policy had never happened, we would have expected to see the same RD estimate over this period of time. So what evidence do we have that would make you think that this is a reasonable assumption? I showed you in the picture, especially in the pre-policy years, the RD estimates are actually quite stable, right? So there was no trend going on there from year to year. But one potential threat is, a key potential threat, is that there may have been some change in other policies that used the pass-fail cutoff that happened in 2009 as well. And there was one. There was a change in retention policy in 2009, which affected some districts and some grades. And I'll come back and say a little bit more about that. But that's an example of the kind of threat that we would be worried about. Yeah?
So a clarifying question and a follow-up question.
Yeah.
The clarifying question is, so you compare the RD from 2009 to 2012 with the average from before 2008 and after 2013.
Yeah.
I'm curious about your decision to include after 2013. I think it's like, as researchers, it's really interesting to look at, but as
Yes.
from a methodological standpoint, it seems curious.
Okay. Do you want to say more about why it's curious, or you just want me to talk about sort of why we did it?
It just doesn't seem like it would, because the idea is to say like what would happen in the absence of the policy, but the
Right.
policy happened, and so it just doesn't seem like, it's not what would have happened in the absence of the policy.
Yeah, thanks for clarifying that, because that is a nice question. So right, it isn't like a world in which the policy had never happened. So maybe the language, the absence of the policy, isn't quite sort of sharp enough. Let me take a second run at it. What we mean by absence of the policy is when this particular rule did not apply to the evaluation of teachers. So the rule definitely turned off, right? It was no longer the case that they could count retests. But your sort of thought raises the possibility that maybe the teachers in schools were changed some way as a result of the retest that influenced outcomes after the policy ended, and that would I can't rule that out. I'm going to show you that we can just focus on just the pre-years and the during years, and the point estimate is quite similar. Okay. In fact, maybe I'm going to do that right now. Yeah, so here, the bottom row of this table is that test. So in the bottom row of this table, this is several robustness tests, which I'll talk about. But the bottom row is what we just talked about, that I can limit the sample to just, in fact, here we're limiting it to 2006 through 2012. So that's using only pre and during years. And in fact, I'm further limiting it to 2006 because there was a change in the math test, a much more subtle change in the math test in 2006. But so if I use only years where the exact same math test was being given, we still get a quite similar estimate of rounding 0.03 or 0.025. There's some other robustness tests here which I think are sort of encouraging. First of all, I guess I'm working up from the bottom on this table. This next section is alternative bandwidths. So these are 3/4 of our preferred bandwidth, 1/2 of our preferred bandwidth, 1/4 of our preferred bandwidth, and we get, again, quite stable estimates at widely varying bandwidths because the relationship is so linear. We can also sort of adjust our difference in RD specification. We can either make, f, remember f was our function of the running variable. We could either make that sort of less flexible or more flexible, and our estimates don't change very much. We can also, instead of using, in the main estimates, we use school by grade by year fixed effects. We can switch to using all of the between school variation and just use grade by year fixed effects. And again, it doesn't change our point estimate very much. So relatively robust to alternative specifications. Let's talk a little bit about magnitude of these estimates. So is 0.03 big or small? So I think there are two comparisons that are useful. The first is to think about 0.03 in comparison to a teacher's total contribution to student test scores. And 0.03 is something like 15 to 30% of the standard deviation in teacher job performance. That is, job performance is measured by their contributions to student test scores, what often gets called teacher value added. So if you think about just a teacher's contribution to student test scores, that's usually the standard deviation of that distribution is 0.15 to 0.2, sometimes as low as 0.1. So 0.03 is sort of a large share of that teacher contribution. If you thought that the entire effect was coming through changes in the teachers, then that's a relevant comparison to make. Another comparison is thinking about other good estimates that we have of adding instructional time. The most sort of comparable estimates, which are not entirely comparable, are a couple of estimates of adding one more week to the school calendar before the test. So I'm sort of showing you an estimate of adding additional instruction after the initial test, but there were different policies over time that added, in different places, that added more time to the school calendar before the initial test. And if we scale that into 1 week, David Sims's estimate is that an additional week gets you like 0.03 standard deviations. My co-authors, Asejo and Romano, have an estimate also from North Carolina that an additional week gets you a little less than 0.02 student standard deviations. So thinking on the time scale of 1, 2, 3 weeks, 0.03 is not sort of all that different from existing estimates. You may or may not like this comparison. Sean may or may not like me listing this comparison, but there are also a couple of papers studying students who were given 2 entire math classes for a full year, or double the amount of math classroom time for a full year. So a full year of twice as much instruction sort of the available estimates suggest get you between 0.17 and 0.2 student standard deviations. So again, 0.03 compared to that entire full year of additional instruction seems like an important effect, even though as a share of the total variation in student test scores, it's not huge. Okay. So the last section, though, probably has the most results of the talk, is to think a little bit about potential mechanisms and threats to our inferences. And actually, some things might be threats to some of you and mechanisms to others of you, depending on sort of how you're thinking about what's going on here. But now I'm going to talk about those potential threats and show you some robustness checks and subsample sort of heterogeneity tests that are relevant to those mechanisms, but they all rely on the basic structure of the main estimate that I've already talked about. So any Any further questions about that? I mean, you can ask them later on too, but I will pause. All right. Okay. So the first thing I want to say in this category of potential mechanisms is, I think, an important point. It rules out a lot of potential explanations for our results. And that is that I'm going to try to convince you that the mechanism here is unlikely to be retesting per se. That it was something about the retest policy, not the experience of being retested for students. Okay? So how am I going to try to convince you of that? I'm going to make use of one feature of the empirical setting here, which I haven't said anything about yet. And that is that retesting did occur in North Carolina before 2009, before the retest policy that we've been talking about, though it was much more limited. It was mechanically similar to the retesting we've been talking about. That is, students who failed the initial test were, in fact, who scored at level 2, were retested 2 to 3 weeks later, just like the policy that I've been talking about. But it was much more limited in scope. It only occurred in grades 3, 5, and 8, not in grades 4, 6, and 7, and only in about a third of the districts in North Carolina. So empirically, what we're going to do is we're going to compare these places where the retesting was happening before the policy to places where it wasn't, grades and places where it wasn't. And it turns out that in these districts and grades, well, this is, I guess, a statement, not a result yet. In these districts and grades, the 2009 policy change was only a change in how the retest affected teacher and school evaluations. Across in 2008 and 2009, kids were retested, and the only thing that changed in 2009 was how the retesting affected the evaluation scores of the adults. Nothing changed for the kids. But I'm going to show you that our estimates are no different, and perhaps even larger, for these districts and grades where there was already retesting. So here are those estimates. There are 4 estimates, because we divide things in that 2x2 matrix. We divide the districts into the districts where there was retesting at the cutoff, and districts where there wasn't, and then grades 3 and 5, and grades 4, 6, and 7. So this estimate here, 0.034, is for grades 3 and 5 in districts where there was retesting at the pass-fail cutoff, even before the policy. And our point estimate there is 0.034, quite similar to our main estimate. So even in places where there was already retesting happening before the policy, we still see this jump in outcomes when the retest policy came into effect. That is when the retesting affected the adults. Our point estimates are actually relatively similar in other districts and in other grades as well. As I said, if anything, they're actually a little bit higher in the places where there was retesting before, but we can't statistically reject that they're the same. So this rules out a lot of hypotheses about what gave rise to our treatment effects, I think, we argue in the paper. Because again, the retesting was constant across this period. The only thing that changed was the stakes for the adults. So if we see some change in results, it's likely to be as a result of something that changed for the adults, the teachers, and the schools more generally. All right. We're going to make use of that here, but let's move on to one category of mechanisms which was already sort of mentioned today, and that is, let's think about the category of mechanisms which do not rely on changes in teacher or school effort. So these would be hypotheses about the mechanisms for the treatment effects that we estimate that would occur even if the teachers didn't change their behavior. So one example is that there could have been changes in student or family effort that was not caused by the teachers, right? So the students or the families started giving more effort, not because the teachers did anything different, but because the students and the families decided on their own to do something different. So for example, students and families might take the retesting as a signal that they should increase their effort. Things are not going well at school, we should hire a tutor, etc. I sort of, even though we don't have any evidence, we have evidence against this, I sort of like this hypothesis. It could be that students themselves find retesting distasteful. They're retested at time t. They say that was a really unpleasant experience. So next year I'm going to give more effort so that I don't get retested again. None of these rely on the teacher changing their behavior in any way. Another hypothesis that some people sometimes raise is this hypothesis that other people have actually found evidence of, that simply sitting for an additional test gives kids additional skills in taking tests. And that might, in fact, boost future test scores, even if the teachers and schools did nothing differently. The kids take another test, they learn better how to take tests, and that shows up in their future test scores. All right, I'm going to show you some evidence that I think is relevant to judging these hypotheses. Anything we should add to our list here of mechanisms which don't rely on changes in teacher or school effort?
I'm a psychologist, so to me it's about all sorts of other things that can be involved in it. Could be that there's a feeling of shame, right? There's that feeling of, well, all of those things that kids feel inside when they fail.
Yeah, right. Yeah. So I've used the word distasteful here, but we could replace that with shame. Like they're retested, they feel this negative psychological experience of having be retested. Maybe entirely internal, maybe prompted by being bullied by their kids or other kids or whatever the case may be. But they get retested and they think that I do not want that to happen again. So I'm going to give more effort next year. But that is slightly different than this, and but I think sort of fits in this category. So thanks. All right, if you have other examples, don't hesitate to share them, but let me show you some of the results. So the first is just to emphasize that the result that I've already showed you rules out a lot of these hypotheses. So just focus in on this negative 0.007 estimate here, close to 0. Again, this is the non-retest policy years, but these kids were being retested. So this is a point estimate of what was happening to kids who were, in fact, being retested and whether or not their outcomes changed. And it does not. Pretty close to 0. An order of magnitude, at least, smaller than the treatment effects. So this doesn't suggest any evidence of the kind that of the hypotheses that we were just talking about, because the kids were being retested. All right. But we can look at some alternative measures, alternative outcomes. One is student absences in the next year. These are things that we have in the data. We would love to measure other things, but these are things we have in the data. So we can look at student absences in the next year. If you thought kids were trying harder during the whole school year, then you might expect them to be more present. That is not the case. We don't find that kids who were retested are coming more often. If anything, well, I guess this does go in the direction you would expect. It is negative, but not statistically significant. If you thought kids were generally giving more effort because they had a bad experience in being retested, you might think that that would spill over into other subjects. But we don't find strong evidence of that. So this is kids who were retested in math, and we look at their reading test scores 1 year later. And it is marginally significant, but again, much smaller than the effect in math. Eric. Yeah. Yeah, even less than a month, maybe 2 or 3 weeks. Yeah.
Then I mean, it might be hard to prepare students for some of the other things. So trying to
Yeah.
think a little bit about what happens there.
Yeah.
It might be that they're favoring one versus the other. You might be able to use the math and the reading and pull them off each other to kind of test them.
Yeah, because we don't find effects in reading. Students were retested in reading. I've been showing you results for math, and that's, one plausible hypothesis for why that be. Maybe it is just easier to move kids further along in math in 2 to 3 weeks than it is in reading. We have a whole bunch of estimates in the literature of all kinds of interventions that seem to affect math more than reading. Thanks. That's a useful thought that we should think more about. Okay. Josh.
So I'm pretty convinced by your identification, but I'm wondering what more about the mechanisms that we think are causing this. So I'm wondering how we actually can envision teachers doing this, like putting more effort into some students in the classroom. It's not like they're kicking kids out of the class. It's not as though they're just focusing on certain material that's going to be relevant to the next test, because if they did that, you'd probably see no effect. So what is, like, how are they actually privileging some students over other students in this way?
It's a good question. I don't think I have anything in the data that will help us adjudicate that. I mean, in some sense, as you'll see, as we finish out here, I think I have evidence that rules out sort of other mechanisms, which sort of leaves us with something happened during those 2 to 3 weeks. But what happened during those 2 to 3 weeks is sort of harder to say much about. So some people have hypothesized that in previous seminars that maybe the schools took all the kids who needed to be retested and put them in one room, and all the other kids in another room. That's one practical answer to the question of how do you go about doing this. We don't have any data that would allow us to say whether that was or was not the case. What else? Sorry, what was the second part of your question?
I mean, no, that's the thrust of the
Okay.
question. It just seems like
What were they teaching them to, right? I don't have any data on that. It's possible that they were teaching them math. It's possible that they were teaching them test-taking strategies that persisted for a year later. I still think whatever they were teaching them, it was more effort different effort being directed at the kids who would be retested. So it's changing teachers' behavior, though it's hard to say exactly what they were teaching them. It could be that they were teaching them the math that was on the retest. And in fact, I'll show you the average change in scores from the initial test to the retest is enormous. So some of that enormous change is just going to be reversion to the mean, but some of it might be that they were teaching them those particular math skills, and that only 0.03 worth of those math skills was still relevant a year later, if that makes sense.
but they're somehow not teaching the other kids, right?
Right.
That's
Yeah.
more, that's the impressive feat.
Yeah. So it's possible they did that within the classroom. Maybe they separated it. They told all the other kids go read or go do this art project. We're gonna right now for the next hour we have math for these kids, but we don't know for sure.
I was wondering, could it be an after school or before school, an additional
Could be that too.
intervention?
Yeah. So this could be a change in effort on the extensive margin that they stick around after school and teach the kids more math, or on the sort of intensive allocation margin of we give more time to some kids and less time to other kids. Both of those would be changes in teachers' effort as a result of the evaluation policy, which is the sort of point I'm trying to make, but I can't tell you which is the case.
Well, one thing is that the retest is happening after the main end of grade task, right?
True.
The instructional year is essentially done for a lot of teachers because what they're being assessed on has already happened for the most part. And so it's not I don't think it's out of reason to think that people have the field day and the retesters don't go, or you
Yeah.
do a movie and then you pull out the other kids at that
Yeah.
Because I grew up in North Carolina.
Yeah. Yeah.
I also do think it's interesting you keep saying teacher changing behavior,
Uh-huh.
but I guess I'm wondering, you can't really rule out that it's also school. I mean, that it's a school policy that retesters get these other things. I mean, to me, that doesn't sound like an individual teacher decision. That more sounds like a school policy.
So it's possible that it's not just an individual teacher decision, though. I think in a very real sense, a school is a weighted average of the teachers, right? Like, I mean, there is a principal, but like the adults in the school are almost all teachers. So they may be taking some collective action. They may be saying, like, we're going to put all the retested kids in one class and have our star math teacher teach them. That's still a decision of the teachers. So I think it's still a change in the behavior of the teachers, but you could think of the school if you prefer to think of it that way. I guess the extreme case where it wasn't the teachers at all is that maybe the teachers said, we're not doing anything different, and the principal said, I'm going to hire a bunch of outside tutors to come and teach these kids after school or during school or something like that. There's no anecdotal evidence from talking to people that anything like that happened, but I can't rule it out in the data, I guess.
Can you identify like a peer effect, like having 90%, 10% of kids in my class be retested? What does that mean?
Yeah, so you want to know, like, this is a good idea, does the difference depend on the percent of kids retested in my class? We should try it at the class level. We basically tried it at the school level by taking the proportion of kids who failed the test at the school level and tested whether the treatment effect covaried with that. It doesn't appear to, at least not strongly. If anything, it looked like schools where there were fewer kids who needed to be retested maybe had slightly larger treatment effects, but that, of course, there's omitted variables bias here too. That could be that, like, schools where there are few kids who need to be retested are also really good schools, and so they're really good at preparing kids for the retest. Okay. One of my colleagues suggested that a lot of these hypotheses about changes in kids' behavior, we should expect to see them more for older kids than for younger kids. So we just looked at treatment effects grade by grade, and it doesn't look like there's any difference. There's no monotonic relationship between grade level and the treatment effects. So this isn't all coming from, like, young kids or all from old kids, where you might expect the scope for changes in kids' behavior are different. But I've probably said more than enough about kids. We've also raised this category of potential mechanisms already, and that is that there's a class of mechanisms which are things that occur in the subsequent school year, after the retest. So I've already said it's entirely plausible in general that lots of things change at the pass-fail cutoff. Things like, a student who just barely fails might get assigned a different kind of teacher or a different kind of peer, or they might be tracked in a different way, or they might be more likely to be retained in grade. In fact, I have a paper that shows some evidence of this happening in the Miami schools, and I'll show you in a moment that it is happening in North Carolina. So other things do change. Assignments do change at that cutoff. However, to be a mechanism that explains the treatment effects that I've shown you, it would need to be the case that those discontinuities were new or smaller or bigger in 2009 to 2012. So as long as that behavior was constant, it would not explain our effects. That's our second identifying assumption, that anything else that was discontinuous at the cutoff is constant over time. So here are a few things that we can measure in the data. The mean year T test score of your T plus 1 peers. So that's sort of a measure of the quality of your peers in the year after the retest happens. The proportion of your T plus 1 peers who failed the test. The value added score of your teacher in year T plus 1, that is her prior value added, measured prior to year T plus 1, and we just say, like, how good is your teacher that you got assigned the next year, and also whether or not you were retained in grade between year T and year T plus 1. So you can see that in our main effect for the regression discontinuity, we actually do see that these things do change discontinuously at the pass-fail cutoff. Kids who barely fail the test end up with better peers, at least higher mean test scores, but then sort of worse peers in the sense that more of their peers have failed. So there's probably some tracking going on of failed and passed kids. They end up with slightly better teachers, though that's marginally significant. And they're slightly more likely to be retained in grade. This is partly driven by the policy that failing should inform retention decisions. But none of that is different in the retest policy years. Okay. Further, the influence of this kind of mechanism is muted empirically because it turns out that most students pass the retest. So think about who in our local average treatment effect is. Who's the population to which we're trying to make inference? It's the students near the cutoff. So the rows of this table are ordered by how many scale score points a student was away from the cutoff on the initial test. So the 1 means these are the kids who barely missed passing. And in fact, among those kids, 62% of them pass on the retest. Not all that surprising, right? There's regression to the mean. They're only 1 point away. So even if there wasn't noise in the measure, we still might expect that a little bit of additional learning or effort would push them over. But 2/3 of them pass on the retest. And their average improvement in test scores between the test and the retest was 0.16 student standard deviations. So if you have in mind some mechanism that turns on whether or not a student failed the test, then most of the kids in our sample sort of inference did pass the test eventually. They just failed the initial test. That said, perhaps we should think of failing the initial test as an instrument for failing the retest, right? Maybe the real treatment here is, did you pass or fail eventually? Did you pass or fail the retest? And what we're picking up here is just that some kids did still fail. 1/3 of them did still fail. So, to be concrete, maybe what's going on here is that our estimate of 0.03 is really a weighted average of 0 effect for the 2/3 of kids who eventually did pass, and 0.08 for the 1/3 of kids who eventually failed. So maybe it's actually something like 0.08, and it all really turns on whether or not you failed or passed the retest. We can't entirely rule that out, or something like that, but let me add one column to this table, same table that I was showing you before. I've just added this column now. And in that column, what we do is we take all the kids who are 1 scale score point away from passing the initial test. We use that sample, and we estimate a regression discontinuity where the running variable is the retest score. So this is the first time we've used the retest score. We're going to make that the running variable for this sample and look at their test scores in math at time t plus 1. So this is the reduced form of this sort of hypothetical instrumental variable setting, and that estimate is basically 0 for the kids near the cutoff. So the 0.03 that I was showing you comes from the initial test score pass-fail cutoff. It doesn't appear to come from, this is indirect evidence, but it doesn't appear to come from the pass-fail cutoff on the retest. Okay. I want to show you one last result and a little bit of discussion, and then I'm done. So if there are people who have saved their questions, there will be time for those. But let me show you one more result, which is unlike the results I've showed you before, but we think is complementary of the results that I've showed before. And that is what I'm going to try to convince you of is that schools changed their testing dates in response to the retest policy. So this would be another kind of behavior or decision by the schools or the adults in the school that was influenced by the retest policy and is consistent with what I've been showing you before. So how are test dates determined? So the state of North Carolina, as is common in other places, defines a testing window. So they say to the schools, you can test in math anytime between this date and this date. And that window is usually 3 or 4.5 school weeks, something in that range. And then the schools choose a date within that window on which they will give that initial test. So if schools are changing in response to the retest policy, then think about this prediction. Schools will choose a date for the initial test late in the window when there is no retest policy, right? When there's no benefit of the retest to the adult's evaluation, they should choose a testing date that's as late in the window as possible. That gives them as much time as possible to teach the kids before the test. But then things change when the retest policy comes into effect. During the retest policy, it's the opposite. I should want to set my test date early in the window, and therefore I have as much time as possible after the initial test before the retest to remediate the kids who need to be retested. Okay, so we find evidence that's consistent with this prediction. That is, the prediction holds for schools who were under accountability pressure. So let me just show you the results. So we're going to define a variable which is intended to capture how much pressure schools felt about their accountability scores as just simply the proportion of kids who failed the test in the school at T-1, so last year. And it turns out that, well, we're going to do sort of a difference in difference estimate here. So this main effect is their choice of test, represents their choice of test dates during the pre-policy years. So it's measured here in the proportion of the window that they wait until they give the test. So, so for every, if we move from, what this is telling you is that as we move from 0% of kids failing at time T-1 to 100% of kids failing at time T-1, the school with 100% of kids failing at time T-1 would have their initial test 13% of the way into the testing window relative to the school that didn't. So that is, they're setting their tests late in the window. But then during the retest years, so we interact the proportion failing with an indicator for the retest years in this sort of difference in differences sense, we reverse out basically all of that effect. So they move their test dates back earlier in the window. But it depends on how much accountability pressure they feel. So the schools that feel more accountability pressure move their test dates more later into the window in the absence of the policy, and they move it up earlier in the window during the policy. Schools that don't feel much accountability pressure don't exploit that margin of change. So this shows up when we use 2007 through 2010. That is when the policy turns on. So here, these estimates are using the 2 years before and after the start of the policy, and we get this pattern of results. We get the same kind of pattern of results if we use the 2 years before and after the policy ends. And the same pattern of results if we use all of the years. Then we do some placebo tests using placebo policy years, and we don't get any difference arising from those placebos. All right. So I want to say a couple of thoughts in conclusion. I've showed you a lot of results, so let me try to summarize what I think are the key takeaways from everything that we've shown you. The first is that I would argue what we've shown you is evidence that's consistent with a distortion of teacher effort induced by performance evaluation. That is, because the state set some specific rules about how teachers would be evaluated, how their performance would be judged, teachers responded to that. Now, this is sort of an unintended response, and a response that maybe we would have hoped not to happen. I guess that's the definition of unintended, but right, it's sort of a negative response, but it is a change in teachers' behavior as a result of the rules that are set for how they will be evaluated. So I said before that this is a distortion in their effort, and it's still a distortion whether students learned more math or learned test-taking skills or both. It's not clear that those sets are disjoint at all, right? They have a lot of overlap. I think importantly, it's counter to the claim that you hear sometimes that teachers are perfectly motivated agents whose effort isn't changed by evaluation. So sometimes, Tom and I were talking earlier about the literature on monetary compensation attached to student test scores, right? There are some experiments and some quasi-experiments, including ones Tom has worked on, that seek to sort of answer the question, if you pay teachers to raise their students' test scores, do they raise their students' test scores? And the evidence is mixed, and some people have argued that the reason we don't see results in those experiments, that we sometimes don't see results in those experiments, is that teachers are already doing what they prefer to do, right? They're already doing, that's not quite the right way to say it, they're already doing what is the right thing to do. That their behavior won't be changed by some outside set of incentives or evaluation because they're perfectly motivated agents. They care about the kids, and so they're already doing the right thing. This is evidence that against that claim, right? This is evidence that, in fact, teachers' behavior can be changed by evaluation. Now, you can take this either in a pessimistic way and say, well, this was a case where somebody didn't think carefully through the rules and it led to an outcome that maybe we didn't want to have happen. Or you can take it optimistically and say, this is evidence that teachers' behavior can be shaped by evaluation rules, and that if we thought more carefully about what those rules were, we might be able to move that behavior in a way that that as a society, or at least as a local education agency or school, we might prefer.
I don't think I'm like that. It seems to me like you could emphasize that teachers are behaving optimally prior to the retest, prior to the first test and between the two tests. A new regime is in place and they're behaving optimally under each of the regimes.
I'm not arguing that they're, so it's entirely possible that they are behaving optimally under the regimes. That's sort of the one of the sort of motivations behind using evaluation as a solution to the principal agent problem. But back at step one, the principal agent problem says there's a difference between what the teacher would prefer to do and what sort of the school or society would prefer them to do. So there are some people who argue that there is no daylight between those two things. that teachers are perfectly, this is sort of, I guess this is super jargony sort of economics language, but that teachers are perfectly motivated agents. There's no gap between those things because they care about that societal objective. So if I show you evidence, as I think I have here today, that in fact, if you change the rules of evaluation, outcomes change, then that's evidence that there is some gap between. Maybe you still disagree, or maybe I'm making some logical sort of misstep.
I don't think I followed it. Maybe let me contemplate.
Okay.
I'm just wondering how much of it, so I think based on the evidence you presented, I buy the argument that there's some gap, but I'm wondering how much of it would be like outside of their, so like if you say you're going to pay teachers more, that's sort of a like, okay, this is part of my like life, part of my work day, but if I know that I have to get like kids to pass in like a 2 or 3 week period, that's like, okay, like I'm going to work really hard, like extra for after school, like get to school at 6:30 a.m., that kind of thing, which is not really
Yeah.
sustainable model for
Right.
teacher behavior. So how do you
Yeah, so yeah, maybe this isn't quite the same thing. So before I say that, I agree. What we've shown you is a very particular change in teacher behavior. I haven't said anything, very intentionally, about whether retesting is some sort of, way to get more effort out of teachers. That's not what we were trying to say in this paper. So I agree completely that, if you lengthened out the period between the initial test and retest, it's not clear that the treatment effects would continue to go up and up. Because maybe teachers are exploiting some margin of effort that isn't sustainable. Maybe they're taking leisure back. Maybe they're giving up leisure, as somebody was suggesting. Maybe they're teaching after school day, so maybe they're giving up leisure. And they would do that over a 2 to 3 week period, but they wouldn't do it over a 6-month period or something. I agree. Yeah.
You mentioned earlier, that you're focusing here on the math, that you also looked at reading or other subjects and did not see it?
Just reading, yeah.
Just reading, okay. And did not see it.
Correct. Not, at least not something statistically significant.
Do you have a thought in that? Is it kind of maybe that math, this whole difference between math and reading, that reading teachers weren't even trying to make that change? Or to me it's an interesting question. Why are we only seeing this in math and reading? If the distortion effect is true, why wouldn't we also be seeing it in reading?
Yeah, so it's entirely possible teachers tried to make this happen in reading as well, and they didn't succeed. Or it's possible that they didn't even try at all, that they only tried in math. Why might that be the case? There's this larger discussion. It's not a perfect regularity, but it is a sort of preponderance of evidence that often we see treatment effects on math, but not reading, especially when we're working through the teachers, like when we try to do something that moves teacher behavior or teacher decisions in an experiment, say. Often effects show up in math, but not in reading. We can have a long discussion about why that is. I'm happy to do that over drinks. Maybe I'll say more if we do it over drinks. But some of the hypotheses have to do with the nature of the reading tests and whether or not they're sensitive to changes in the kinds of things that teachers are doing in schools. And if teachers didn't think that that was the case, if they didn't think that the tests were capturing what they were doing, then maybe they wouldn't have much incentive to try to do this in reading. There are other sort of hypotheses from people who actually study the development of reading about how quickly it's malleable, how could you have had improvements over the course of 2 or 3 weeks, those kinds of things. And there's a long discussion because it's a challenge that comes up pretty regularly on lots of different interventions.
The question is just have you looked at the other effects of the second test? And specifically, if we think that there's this conditional on some sort of labelability, there's a stochastic element to your student's test score in a given day, then mechanically just giving every kid a second test is going to raise the conditional uncertainty probability of testing or passing from one year to the next, right? So I guess my question is do you see what's the effect of that, or have you all looked at that?
Okay, so I'll take that last part last, but it is definitely the case that there is measurement error and other sources of noise in any given test. In fact, we're sort of relying on that in the identifying assumption, the identification strategy of the regression discontinuity. We're saying these kids who are close to the cutoff are arguably identical, and what caused them to be just above or below the cutoff was sort of partly noise on the day of the test. So if we had, so that's part of why there are big improvements in test scores on the retest. All of that's consistent with that. That's why we look at test scores 1 year later and use kids just above and below the test score. Because if those kids are just above and below the test score are identical in general, one of the ways in which they're identical, at least at expectation, is in the degree of noise in their initial test. So if there was some noise that was going to cause kids to go up or down in the year T+1 test, that should be also continuous at the cutoff. So that's sort of baked into the reason for using the regression discontinuity as a quasi-experiment and using the test score 1 year later. Were there other effects of this policy? I don't know. We have not looked at any. We would certainly be interested in hypotheses that people have about other effects of the policy. It definitely, if you were not careful, it would definitely give you the impression that things suddenly got a whole lot better in the schools, right? So the Wake County school system, which is, Raleigh and Durham and whatnot, they were thoughtful. They're a good example. So when they prepared their reports showing test scores over time, they had bar charts that showed average kids failing or average kids passing, whichever. And then during the retest years, they had a stacked bar where they showed what the passing rate would have been on the initial test and then how many kids were only passing on the retest to emphasize to their readers, look, this isn't some miraculous jump up. But you could imagine other places in which they weren't thoughtful about that, and it led to some changes in outcomes for kids that either made kids better or worse off. I don't know. We haven't looked at any of that. Any last things to say? I haven't said anything about whether this distortion of teacher effort was good for students. What we observe is differences in math test scores at the pass-fail cutoff. We don't observe, we can't tell you much about the absolute levels of test scores or certainly can't tell you about total welfare of students. But just back to a point that I started with, and yet, so you might think we haven't said much at all, but remember, the kids who were just above and below the cutoff and who were retested or not were arguably identical in the sense that they had equal claim on the effort from their teachers. They had equal return on that effort, and yet they got different effort and different outcomes. So I think that seems about as close as I'm going to get to a sort of normative statement about these outcomes. It does seem like that was unintended, that we should probably not want that to happen. But whether or not total welfare went up or down, we can't say. And there are 3 minutes left. So we can either end or you can raise your hand and ask more questions.
So total welfare seems like the right thing to care about.
Yeah, absolutely. Yeah.
Because part of what schools do is they have to categorize or organize kids in ways to deliver instruction to them.
Yes.
The fact that we say if you're born on August 31st or September
Right.
1st, you're in a different grade, those kids have equal claim to whatever, right?
Right? And yet have different outcomes.
You can't start every kid on a different day.
Yeah.
So we do this all the time of sort of trying to figure out how to deliver group-based services to kids who differ in multidimensional continuous ways.
Yeah.
And it's sort of not surprising that then that leads to some, at the margin, the discontinuity, you see some different
consequences and outcomes. But it seems really important to know whether it hurt one group of
Yeah.
kids or helped the other group of kids relative to some.
What would have happened otherwise? Yeah.
Is there no way you can use the kind of stability of the test over time to say who really got helped or who got hurt? It's the same test over certain sets of years, right?
Yeah.
Because at some point, this tells us something about mechanisms, which is useful, but it doesn't tell us whether this was a good policy or not.
Right.
And so,
Correct.
depending which you want, I think
Yeah.
it's satisfying or unsatisfying.
Yeah. I'm sort of satisfied because I was curious about like whether or not teachers' behavior responded to these particular features of evaluation. But it's an important point to say in these last few minutes that this is not a statement about whether or not the policy was good or not. One example that I always think of is it's possible that schools are allocating time and effort across the school year, so maybe they focus more time on math before the math test, but then they switch to things like art or science or whatever in those last few weeks. And so it could very well be that the kids who were retested got better at math but missed out on art. I think, depending on what weights we put on those subjects in welfare function, they might well be worse off. I do worry about that. So we're not trying to say something here about whether the policy was good or bad in total, though maybe we should try harder to see what we could say. We were after this very particular question from personnel economics. So. But it may have been a good policy, may have been a bad policy. That's a good place to end. We're answering a very specific question. All right. Thank you so much.